You just failed your physics exam because you don't go to Sigma. Your parents ask for your marks. You give them your marks and they look at you. They start going like this and then they run towards you. What is that called? That, my friends, is relative velocity. Because like your mum's your relative and stuff. And they're like moving towards you and stuff. For most year 11 students, I'm going to get rid of that. For most year 11 students, there's a special place in hell for relative velocity problems. So I want to go through with you kind of like the standard relative velocity problems, which is not a perpendicular one, and help you get that extra marks. Mark. Easy peasy, let's go. So it all revolves around our relative velocity formula, which is VA rho B is VA minus VB. First thing you do, we change the expression to VA plus negative VP, because again, snap kick to the head, that tells you got to flip your VB vector. So what's the actual question, Chris? Let's have a look. Just going to move this equation over to the side. Now, how's that for quality video editing? So let's make this some random angle, maybe about 6-7 degrees. So pretty stock standard question. Car A is going north, car B is going at some random angle. Find the velocity of one relative to the other. So firstly, let's draw out our vectors, but recognize we need to flip the velocity vector for car B. So if car B is going south 67 degrees east, all you do is you change the south to a north and the east to a west. So the negative velocity vector is north 67 degrees west. Now all we need to do is break up our velocity B vector into components. Next thing I like to get my students to do is to draw a table, something like the following. So essentially all we do is we split up our individual vectors into components and then we sum down the columns to figure out the resultants of the components. So vector A, you see it's 20 meters per second north, so all we do is we just add a plus 20 to the north-south column and a 0 to the east-west column. Now vector B, you see we've got 17.2 cos 67 in our north-south and we've got 17.2 sine 67 in our east-west. So everyone knows cos 67 is about 0.39. So 17.2 times 0.39 gives you about 6.7. So our north-south component is therefore plus 6.7. The east-west component, so 17.2 sine 67. Again, everyone knows sine 67 is 0.92. So 17.2 times 0.92, we get about 15.8. Now do note this one here is towards the west. So instead of putting a plus, we're going to put a minus because, convention says northeast positive, southwest negative. So therefore the east-west component here is going to be negative 15.8. Now that we've got the component values for the individual vectors, sum down the columns to find the resultant or the net component. Okay, little pro tips just to make sure you put in the pluses and the minuses so when it comes to adding the components together, you don't make a silly mistake. Now that we've got the components of our resultant vector, let's do some vector addition, put them together, Pythag arctan that shiz, and let's find the resultant magnitude and angle. I'll always get my students to draw the north-south components first because when you define the angle, it will then be relative to the north-south axis, and that's what teachers want. No one likes east 47 degrees north. Who does that? If your teacher does that, I apologize. I'm sorry for you. Okay, so all we do now is we're going to do Pythagoras to find the magnitude of the resultant. We'll then do arctan to find the angle. All right, so you guys heading into year 12 now, you should be able to do Pythagoras in your head pretty much. Okay, so V is going to be square root of 26.7 squared plus 15.8 squared. That'll be square root of about 962, which will be around about 31. Okay, so V is equal to, or the magnitude of V will be equal to 31 meters per second. Now the angle, you guys should also probably pretty much be able to do arctan in your head as well. Okay, so arctan of this angle is going to be opposite over adjacent. So 15.8 divided by 26.7, that's pretty close to 0.6. And everyone knows arctan of 0.6 is about 31 degrees. Okay, so we end up with theta here is equal to 31 degrees. So the answer is 31 meters per second at 31 degrees. Make sure you make that angle relative to something. So it's going to be north 31 degrees towards the west. Easy peasy. So the relative velocity of car A compared to car B, so the velocity of car A rel car B is 31 meters per second, north 31 degrees towards the west. Easy peasy, got you an extra mark.